From the moment of our birth, we enter a world that is a social world, full of relationships. As mammals, our first relationship is a necessary one with our mothers. While initially that represents a relationship that's cemented by lactational glue, it quickly becomes a more nuanced, complicated, and rich relationship. As we move from infancy to childhood to adulthood, the circle of our social relationship expands to include playground peers, to include schoolmates, and to include work and play-related partners. Perhaps the culmination of the social relationships we experience is the one that's characterized by a strong emotional attachment, a romantic feeling, and sexual interactions. That's a science way of describing falling in love. Now, this tendency to form relationships is not unique to humans or other complicated organisms. In fact, even the simplest organisms on the earth form relationships with others of their like kind for a variety of benefits, including reproduction, including protection, and many other benefits. In addition, even simple organisms can recognize other organisms that pose a risk to them, and they avoid those individuals. Now, in simple organisms, these formation of groups and avoidance of animals who could do you harm are mediated by chemical signals. Modern neuroscience, the science of the brain, has also revealed that the formation and maintenance of relationships in humans and other animals is also mediated by the soup of chemicals that we find inside our brains. As a matter of fact, there's an age-old adage that we use to describe either a good romantic relationship or close friends. There's a good chemistry between us. This age-old saying presaged what modern neuroscience has discovered about the biological basis of social relationships. One of the key suspects in mediating social behavior in higher animals is the hormone oxytocin. It's a simple 9-amino acid hormone, amino acids being the building blocks of life, that is evolutionarily very ancient. It first appeared 500 million years ago in the ancestor of the sea lamprey. While it initially served important functions in water balance, it soon came to regulate social behavior. Oxytocin is synthesized in an almond-sized structure at the base of our brain called the hypothalamus. Oxytocin has two targets in the body. In the periphery, the smooth muscle in the uterus and the smooth muscle in the mammary gland are particular targets of oxytocin. Oxytocin mediates uterine contractions that produce birth and milk ejection that sustains a young mammal. The second target for oxytocin in the body is in the brain itself. We know that oxytocin communicates with regions of the brain that are involved in mood and emotion. We know that oxytocin communicates with regions of the brain that are involved in reward and fear and anxiety, and perhaps most importantly for humans, in regions of the brain that help us to interpret the meaning of social signals. Basic research in neuroscience has found that oxytocin facilitates a whole host of what we refer to as pro-social behavior. Oxytocin can increase our ability to read facial expressions for emotions and voice tone. Oxytocin can enhance trust with others in a cooperative game. Oxytocin can even lead to enhanced marital satisfaction. From the clinical side, oxytocin has also been used widely in a wide variety of disorders. You may be most familiar with the use of oxytocin in the treatment of autism, But it's also important in the treatment of anxiety, in the treatment of postpartum depression, in the treatment of male sexual function, in the treatment of female sexual function, in the treatment of drug disorders, and yes, oxytocin may even cure the ringing in your ears. All right. The basic and the clinical science, therefore, has led to a perspective that oxytocin is a molecule that allows us to see our social world through rose-colored glasses, that it enhances positive and pro-social behavior. Is oxytocin the magic chemical that can cure all of our social ills? More recent research, which I'm going to touch a little bit on today, suggests that there may be a dark side to oxytocin. And as a matter of fact, under some conditions, oxytocin may make us view the social world through gray-colored glasses. For the rest of my talk, I'm going to be describing a couple of experiments with 2 primates, 1 human beings and 2 marmosets. Let's start with a 2-legged primate. Let me pose to you the trolley dilemma. You are sitting at the switch in a track. You're the one with the question mark over your head. You see a train hurtling down the track. If you do nothing, 5 people will be run over and killed by the trolley. On the other hand, if you pull the switch and redirect the trolley, 1 person will be killed. So here's the dilemma. Do you let nature take its course? 5 people are killed, a greater ill. Or do you throw the switch and reduce the number of people that are killed, but a person who would otherwise be normal and unharmed is killed because of your act? What would you do? A group of Dutch neuroscientists used this particular trolley dilemma to study how oxytocin may regulate social decision-making in this context. They also provided subjects with a little bit of additional information. Instead of being anonymous people, they gave a name to the person on the top of the track that would be killed. In some cases, the name was a typical Dutch name, Dirk or Peter. In other cases, the name of the individual was Ahmed, an Arabic name, or Marcus, a German name, designed to produce in-group and out-group. Subjects were treated with oxytocin or a saline injection and asked how many times would you pull the switch that would kill this person whose name you know. Under control conditions, that targeted individual was sacrificed at moderate rates with a slight bias toward the out-group Arabic or German name. Under oxytocin, the Dutch subjects reduced the number of Dutch named targets that they killed, again, consistent with this pro-social nature of oxytocin. On the other hand, it increased the number of out-group named individuals that were killed. So in this particular case, oxytocin enhanced prosociality toward in-group, but enhanced discrimination and bias toward out-group individuals. All right, on to the 4-legged primate. Marmosets are South American monkeys that are about the size of a squirrel. They live in the southeast coast of Brazil, and they live in social groups that are very much like human families, male and female, younger offspring, and older brothers and sisters, all of whom help rear offspring. Now, our initial work on oxytocin showed that treatment with oxytocin enhanced the process of falling in love for new marmoset couples. If they got oxytocin, they groomed each other more often, they exchanged food more often, and just hung out on a branch in close proximity to each other more often. But we did 2 experiments in which we manipulated oxytocin in well-established pairs of marmosets. The first paradigm is shown here. We allowed the marmoset at the bottom to meander through this T-maze and spend time either with its own mate on the left or with a stranger on the right. This is a marmoset version of Tinder. Swipe left for your mate, swipe right for the stranger. Now, under normal conditions, marmosets like their mates, but they also are intrigued by the exotic stranger. What happens when we increase oxytocin? Very simple findings. First of all, administering oxytocin had no effect on interactions with the partner. It didn't make them love each other more. What happened was it reduced the marmoset's normal interest in exploring and interacting with the exotic stranger. Again, this is a negative side. It reduces normal social exploration in the marmoset. The final task was a test of altruism in marmosets. In this particular case, the animal on the right can pull a tray containing food rewards. The animal does that very well when he or she gets a Cheerio. But here's the altruism test. Is the animal willing to do that, perform that response, when they receive nothing, but the partner gets a treat? Again, we did this test with long-term pair mates, and we did this test with strange male-female partners who were unfamiliar with each other. Again, when we brought oxytocin on board for these marmosets, we found similar patterns of results. Oxytocin treatment did not enhance altruism toward the partner. It was maintained at the normal rates. However, oxytocin did reduce the altruism that was displayed toward the stranger. Okay, there is one very simple lesson from my brief review of literature that's, again, been described as the dark side of oxytocin. The same molecule that can form a strong mother-infant bond can also enhance discrimination and bias against outgroup individuals. The same molecule that can enhance love and friendship can also produce reduced interactions with strangers that we may meet. The same molecule that enhances trust and empathy can also reduce kindness and altruism toward strangers. Now, from the clinical perspective, this new view of oxytocin is particularly relevant. If we treat an individual for one social deficit, is it worth it if by treating the individual, we create 3 additional social deficits? From the perspective of understanding the way in which our brain helps us navigate the social world, it also helps us understand why, in spite of both individual and collective efforts to the contrary, things like bias, discrimination, and ethnocentrism, unwillingness to interact with strangers, and a lack of cooperation continue to persist and be important parts of our social world. Thank you.